Hello and welcome to TidyX episode 119. TidyX is a screencast where we go through to explain how our code works. My name's Ellis Hughes.
And my name is Patrick Ward. And today we're talking about random sampling from groups using tidyverse. It's a total slice and dice type of episode. Yeah.
Slice and dice. So
Yeah.
this should be
So,
a fun episode here that we've got going on.
yeah. And this, as we go through these kind of like data engineering, data cleaning, data preparation type of episodes, this is kind of an interesting one because it's very much in the vein of things that we've done before, where we've talked about random sampling for class imbalance issues when we did our full Bayes series. That was a ton of
Yeah.
sampling
Oh
for
yeah.
Monte Carlo purposes and
Mm-hmm.
bootstrapping and all those
Yep.
kinds of things. So,
And then also for
um,
our when we did the series with tidy models as well, we also had to
totally.
deal with like class imbalances and dealing with classes and
Exactly.
sampling from that. So and the
Yeah.
bootstrapping and whatnot.
Yeah. So
So
this is a very it's a common practice when you're cleaning data and preparing data or analyzing data to take random samples from your data. So let's break this
let's
down
just
in
get
a
into
clear
this. Let's
way
pull
and
this
yeah,
over.
in
Let me
tidyverse.
pull our screens over here to the right so you can see what we're doing. So I'll take us. I'll build the data. Patrick, you kind of talk through the sampling that we're going to be doing here.
Okay. Yeah. Mhm.
So first we're going to bring up tidyverse for all our data manipulation and data needs. And it got all the dplyr, tidyr, all those functions. We're going to build up our data set by first building up a couple vectors. This first one we're going to call group, and this is going to be the grouping vector that we're going to be using, or the grouping column eventually that we're going to be using across this episode here. Next, we're going to generate two random variables using the R norm. So this is pulling from the normal distribution of random number, random values from this n times. So we're going to pull a length of group, which group here is 19. So we have 3a, 6b, and 10c values. We're going to have a mean of 0 and a standard deviation of 1 for var1, and a mean of 10 and standard deviation of 5. Ultimately, these are just demo values for us to work with. This week, there's not really any real representation that's going on here. We're going to create our data set using data.frame and drop in group var1 and var2. And data frame does a nifty thing where it uses the value that you put here. It does a substitute and pulls that actual value here. So in dat, we have automatically group 1, var1, var2. So that's kind of a way you could get away without having to actually specify column names, which I think a lot of people do. So we can take a quick head of there, and we can see the data that we got here. So we've got group A, or in the head here, it's 3 A's and 3 B's because head only shows the top 6 rows, and then some
Mhm.
random values, but that doesn't matter. Patrick, you want to take it from
Yeah.
here?
So now we have a data set, and so we can kind of pretend like maybe we're doing some research on schools, and we're sampling schools from different counties or different cities, and we have different representations of numbers of schools within different cities. Like maybe the city of Seattle, we have 3 schools, in Renton we have 6 schools, in Redmond we have 10 schools. Or it could be sports teams or whatever it is. You've got this group, and you're sampling, and you have different representations of those samples. And so let's say first what we want to do is maybe just get four. We'll just do like a random sample of all the data that we have, and let's just say, hey, randomly pluck out 4 variables. Obviously, C and B have a higher probability of coming into the random sample than A, because A is only 3 out of the what is it, 20? 3 out of the 20,
19.
3 out of the 19 total observations that we have. So that's an easy way to just pull a sample randomly from the data. Obviously, like if we're doing an analysis, we're probably not so concerned about all of the observations just randomly sampling from them as we are perhaps randomly sampling from the actual groups themselves. So we can actually do that by just plugging in group by here. So group by is basically saying, hey, take our data frame called dat, which houses our data, and group by group. So go through each of those individual groups and take a sample using the slice sample function of 4 observations. And notice that we have to use this replace equals true argument because group B and C have, or sorry, because group A only has 3 observations. If we're asking for n number of observations that are greater than the number of observations in our group, ours is just going to bark out an error because it's going to say, well, I tried to get 4, but once I hit 3, I couldn't do anything. There's nothing else for me to choose. So if we pass that replace equals true, what it does is it says, hey, I've grabbed 3, and I can just grab randomly one more observation. And so you could see it grabbed whatever that observation there, 2, 3, and 4, at the same time out of the 3 observations.
So it'll randomly do this every single time. So
Yeah,
it's a random operation every single
and
time.
so that's if we wanted to, if we wanted to sample by a specific number. Ellis, what if we wanted to sample by, like, let's say, like a proportion of the data
Yeah,
instead?
like say we know that we just want to get 25% from each group.
Yeah.
Knowing that it's unbalanced and we don't want to specify exactly how many we have. We just know that we want roughly a quarter of them. So let's take a quick count of the number of groups or the number of samples we have in every group using the count function. So that again confirms, what we've been saying: 3 from group A, 6 from group B, and 10 from group C. And so what we can do if we know we just want to take a flat 25% off of each group, we take that, we again do the group by, but rather than using a slice sample, a slice sample, what we're going to use here is sample frac. And so sample frac is a function that's in dplyr. It is superseded. And so this is important to note when you're using functions in tidyverse, is they sometimes note functions that they're no longer going to be progressing forward, no longer going to be developing. Superseded is still safe to use as a function. A function that is superseded is still safe to use. They are going to maintain it. If there's bugs, they will fix them. At least that's how I understand the life cycle meaning.
So, quick question. If someone were to use this function, how would they know that it was superseded or not?
That's a great question. So what you can do is if you're using the latest version of the package, you can type $sample frac or whatever your function is. This is going to bring up the help pages. And one of the great things about RStudio and the developers there is they do their very best to make sure the documentation is fantastic. And as you can see here, the very top of the documentation for sample frac and also sample n is that they are now labeled as superseded. And so here we go. They've got a example of what they mean. It's we realize that it's more convenient to have a single function that's going to be representing sample frac and sample n, and that's what slice sample is, rather than maintaining 2 separate functions. And so they've put that into the single function slice sample, but we decided in this situation that we wanted to use sample frac for a specific reason. We'll go over that in a second. But let's first run this. So once again, take that, go to group by, and then say, okay, we want a quarter of each of the samples, and replace is true. So if you need to resample, go ahead and do that. So if we run that, we're able to pull it out. We're able to get 1 record from group A, which makes sense because if you're trying to take 25% of the 3 samples, you should only have 1. We get 2 records from group B. Again, that kind of makes sense because if you have 6 records, 25% of that is math. But it's going to round up to 2, and then 25% of 10 is 2.5, so it's going to round down in this situation down to 2 records as well. It could potentially round it up, but they chose to round down. So that's how they did that. Now, if you wanted to use the current functions that they're suggesting to use, the way you do that with sample slice is you set, rather than n, which is what we did up here, we can use the prop argument. And in sample slice, you either need to set the prop or n indicating number of records to keep, prop meaning the proportion of records to keep or to slice from. And so you can run this and you can say, oh, that's a different response. And the reason is in the documentation, you may notice, of slice sample, they state, let me see here, if the proportion of a group size does not yield an integer number of rows, the absolute value of prop nrow.data is rounded down. And so in this situation, we have groups of 3, 6, and 10. Multiply that by 0.25, which is our proportion. Helps if I set it up as an actual integer here. So we get proportions of 0.75, 1.5, and 2.5. But they're rounding down, which is the equivalent of floor. And so in this situation, you get 0, 1, and 2. And that's why so just keep that in mind if you're doing sample fraction versus sample slice. Their behavior isn't identical. And so this may be fixed in the future, but for right now, the behavior is slightly different. So might bring that up with them in the future, the developers, which is a great thing that they're so receptive. But yeah, so this is how you could use sample slice, and here's how you can use sample frac. Similar arguments, similar way that you'd set things up. They just are, just different design decisions as they went.
Mm-hmm.
Okay, but what if we did want to? We've been sampling number of records or proportion of records, but what if we wanted to get it so every group had the same number of 5 observations?
Yeah.
Patrick?
Well, yeah, we can wrap a bunch of these together. And the way that I kind of wrote it here was to use bind rows. So bind rows is sort of like if you're in base R and you did a R bind function, it's basically saying take the rows of one data frame and then take the rows of another data frame and dump them onto the bottom, and take the rows of another data frame and dump them onto the bottom. So bind underscore rows is the tidyverse analog to that. And so what I did was I said, you know what, let's first start with group A and just filter them out of the data. So we're going to grab those 3 observations from A. We're going to do a slice sample of 5. We have to do this with replacement because there are only 3 observations. Then we're going to filter out group B, and we're going to do 5 slices of that data as well randomly, and we're going to do replacement with that. And then for group C, since we have 9 observations, we're going to do n equals 5, and we're going to say replace equals false. So there can never be a repeated observation in the sample for group C, and we wrap those all into our bind rows, and that gives us a new data frame of 5 observations per group, and randomly sampled. So because we didn't set a seed here, so if you were trying to do this for replication purposes, you would want to set a seed. So if you were doing this for like a publication or science or something like that, and you needed to make sure that people could recreate your work for certain reasons, setting that seed becomes really, really important, because you want to make sure that you always get the same sample return. Otherwise, if you just always want to kind of, pull the slot machine lever, then don't set a seed and just let them ride, and you'll get a different sample every time. And there's no guarantee that what you'll have is exactly replicable, but you get what you get.
Sometimes you got to do that. Sometimes there are scenarios where it makes sense to look, it's got to be completely random.
Totally random. So yeah, that's what it is.
But that's how you can go about slicing and dicing using the tidyverse, pulling out samples from your data sets, slicing out of there. I kind of like because I like using slice. And I like the name change because there's another family of slice functions in tidyverse. So it kind of keeps that idea together where you're slicing your data up. So you've got just slice where you identify which rows you want to be pulling out or total number of rows, slice head, slice tail, slice min, slice max, telling you, and then slice sample. So it's like the family of slice.
Yeah. I mean, it makes sense as to why they condensed everything down to, these few functions all with the same prefix. So.
Exactly. And so that's just good design. So so with that, I think we're going to end episode 119 of TidyX. Hopefully you learned a little bit about slicing and dicing your data. As always, my name's Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. On Twitter, I'm at OSPPatrick, and at Tidy_explained is where you can find the screencast on Twitter and tweet us. You can email us, tidy.explained@gmail.com, of course. But the main way people mostly like to hit us up is on YouTube by liking and subscribing and dropping a comment underneath the video. And we tend to respond to those the easiest. So go ahead and do that if you'd like. Otherwise, if you enjoy the screencast, you feel like our work has impacted you and your work in a positive way, we do have a Patreon page, and we're always grateful for any contribution that you make to our work.
Yeah. Thank you all so much, and keep on exploring your world.